This is question number 6 from exercise 6.1 based on increasing and decreasing function. In this question, we have to find the interval on which the function is strictly increasing or strictly decreasing, this being the function here. Now for solving, finding its derivative, we are going to apply this product rule. Let's say if I consider the function as fx, so fx is equal to, as I said, we are going to apply product rule. So let's say if I take this as u and the other as v, x minus 3 whole cube. Now to get f dash x, so first it is u dash, so differentiation of this is 3x plus 1 square, and for from chain rule x plus 1 is 1, so we don't write 1. U dash, then v, this being v, plus uv dash. So first I'm finding the derivative of this, which is 3x minus 3 whole square, that is v dash u, and u being this. Now we can figure out that we have 3 as common, so we can take 3 as common. Outside we have 3 as common. We have x plus 1 square times common from these two, and x minus 3 again square times is common. So what we are left inside, from here we are getting x minus 3, and plus from here we are getting x plus 1. So this is f dash x. Now we'll continue to simplify it further. So this is x plus x is what? 2x. 2x minus 2, like minus 3 plus 1 is minus 2. So we can take 2 common here. So if I take 2 common from here, if I take 2 common from here, this will become 6. So I'll do it here only, taking 2 common from here. So it will turn out to be x minus 1, and that 2 taken common will multiply with 6 to give you 6, with 3 to get 6. Now equating with zeros, we'll get equating this with 0, we'll get x is equal to minus 1. Equating this with 0, we are getting x is equal to 3, and equating this with 0, we are getting x is equal to 1. So we'll say that here these values divides the real line in 3 disjoint interval. So the interval here, the interval is going to be minus infinity. Say this is positive infinity. Over here, it was minus 1. So this is minus 1. Then this being 1. And this is 3. Now we are going to check the sign of f dash x. So let's say in the first interval, it is minus infinity to minus 1. So if I place any value which is between these two, say minus 2, if you plug in x as minus 2 over here, we are going to get a negative sign, right? We'll get a small negative sign. In that case, we'll be writing this as, that means in this interval, that is minus infinity to minus 1, we're getting this as negative. So if it is negative, we say this is strictly decreasing. Now over the other interval, that is the other interval, the second interval is this. Let's say if I place minus 1 to 1, I can place 0, right? If I place 0 here, this is positive, and this is negative, right? So again, here also we are getting, sorry, in this case, here also we are getting negative. So we'll be writing in this interval, again, we are getting an overall sign as sign of f dash x is negative. So again, it is strictly decreasing. Now for the third interval, in the third interval, that is in this interval, between 1 to 3. So if you place any value between 1 to 3, like say, for example, if I place 2 here, so it's a positive, positive, and 2 minus 1 is 1, which is positive. So we are getting a positive value here. So we'll write down for the next interval. That means between 1 and 3, we are getting an overall sign of f dash x as positive. So this is strictly increasing. Further, if we find for the last interval, that is from 3 to infinity, 3 to infinity, that means if I plug in x as 4, so we are going to get this as positive. It's a square number is always positive. That's the reason. And this is 4 minus 1, which is 3, which is again a positive. So we'll say that the overall sign of f dash x is positive. So it is again increasing here. So the final statement that you should write down is, so you'll say that fx is strictly increasing in the interval, that is 1, 2, 3. You may write union or you may place and 3 to positive infinity, and is strictly decreasing. You don't use arrow in the exam, write down the statement, strictly decreasing in the interval, that is minus infinity to -1 and -1 to 1. This is how you should end the answer.